When it comes to raw materials, particularly metals, or even completed sub-assemblies made of mixed materials, how do you really know the makeup of the materials that you receive? And are they what you expected, or are they what is allowed, or the quantities allowed by law? Well, there is a device called an XRF, or X-ray fluorescence analyzer, that allows you to directly read the type and amount of particular metals in a sample. So here on the show with us today to explain a bit about XRF analyzers is Dianne Hillhouse of Olympus. Hi, Dianne.
Hi there. How are you?
Fine, thank you. Thanks for joining us. So just briefly, for those of our viewers who don't know, can you describe what an XRF analyzer is?
Sure, absolutely. Like you mentioned, XRF stands for X-ray fluorescence, and an XRF analyzer is a very handy and powerful tool used to determine material chemistry rapidly and non-destructively. And here's what one looks like.
Oh, there we go.
Okay. Oh, did I cut out? Should I start again?
No, you got it. We got it. Yep.
Okay. So this is what one looks like. Some people say it looks like a radar gun or a Star Trek phaser. And the way it works is the analyzer uses very low-level X-rays to energize or excite a sample, and then it's enough energy so that the sample itself emits its own signature characteristic X-rays. And then the analyzer takes those signature X-rays and determines what elements in the elements in the periodic table, the sample contains, and then also a concentration of those elements. And a handheld XRF analyzer can generate a chemistry in metals and alloys, in plastic, like you mentioned earlier, the hazardous substances, the RoHS regulations, as well as glass, soils, sediments, rocks, liquids, pretty much anything where there's an elemental concentration that the analyzer can recognize.
And Dianne, how are they typically used in industry? How would a typical manufacturer use an XRF analyzer, and why would they?
So the most common use is to sort and identify metals and alloys, and they're using it for quality control, for product reliability, for product safety. Handheld XRF, it's very commonly used and widely accepted to verify incoming material and then outgoing finished product in a manufacturing or fabrication setting. And then there'll be a handheld XRF analyzer ready to greet those same finished products at the door of a warehouse of an oil refinery or a petrochemical plant or a pharmaceutical plant or a power plant. And they will use that handheld XRF analyzer to, again, take a look at the material once it arrives. They'll take a look at it prior to installing it in whatever process or unit they plan to use it in. They'll continue to use a handheld XRF analyzer to take a look at these same parts and components during the lifetime of this unit or process that they're installed in. And then once those parts and components are ready to be decommissioned and recycled, you'll find a handheld XRF analyzer in those scrap recycling facilities where they're sorting that scrap, getting it ready to send it on to a mill or a foundry to be made into new metal. And then those foundries and mills will also have handheld XRF analyzers. They're going to check that incoming material one more time. They'll use a handheld XRF analyzer throughout their process to make sure that the chemistry stays very tight on this new metal.
So you use it all over the place.
Absolutely, all through new metal manufacturing, product fabrication, in service, in use.
Now, you just showed us, and you've referred to it several times, a handheld unit. And it sounds like the function that you're describing is really important, but in the past, how was this type of analysis done, or was it? Is this something that's just, now that it's handheld, we can do things that we couldn't even do in the past?
Well, X-ray fluorescence itself, it's a classic technology. It's been around for a long time. It's first commercially available in the 1950s. But prior to that, and even now, you'll hear people talk about really simple and inexpensive techniques to tell the difference between metals and alloys. You might hear somebody talking about grinding a metal and taking a look at the color of the sparks, or you might hear someone talk about eddy current technology, or maybe something as simple as using a magnet to tell the difference between ferrous and non-ferrous material. I have folks tell me they can taste the metal and tell the difference. And actually, these are all pretty valid techniques, but as long as you don't want to sort alloys very specifically. Today, I mean, there are thousands and thousands of alloys and really infinite possibilities of modifying these existing alloys. So, it's hard to tell the difference between these alloys that look very similar and have very similar chemistries without understanding, understanding what elements are in there and what concentrations. So you really have to have something like a handheld XRF to do this.
Dianne, handheld X-ray might sound maybe scary to some people. I mean, it's X-rays, right? I mean, so what kind of radiation levels are we talking about here? Are there any special precautions that folks need to take when they use these analyzers?
Well, most states and regulatory bodies, I mean, they're going to require the proper training, which Olympus and any other manufacturer is going to give the customer. So again, they're widely used, they're widely accepted, but I understand that X-rays and radiation do sound scary. Now you're actually getting more radiation from your everyday activities, such as standing out in the sun or flying on an airplane, than you would ever get from a handheld XRF analyzer. The X-rays and the radiation are measured in a unit called millirems, and our governing bodies and regulatory bodies that are there to keep us safe. They give folks who use radiation equipment an allowance of 50,000 millirems per year. And that includes people who use handheld XRF analyzers. It includes people who are doing industrial radiography or using medical X-ray devices as well. And a handheld XRF analyzer, it produces about 0.1 millirems per hour with proper usage. And so if you're given this figure, you could use a handheld XRF analyzer all day long, every day of the year, except for weekends and holidays, and you would still be under 1% of that 50,000.
Probably certainly safer than tasting lead or cadmium.
Yes, I was going to say.
I'm not sure I want to go around licking cadmium all day long. It's a good idea. Yeah. I mentioned, and you did RoHS, the reduction of hazardous material standard, which limits the amount of certain heavy metals in particular in products. Would this same type of instrument be used by, big box stores, for instance, for checking the hazardous materials in consumer goods? I'm thinking, in particular, several years ago there was, lead in certain, toy imports and that sort of stuff. Would these kind of companies use it?
Yeah, absolutely. These finished products, you have, whether they're made in the United States or elsewhere, when they're imported in or exported, they're going to be checked. And then prior to them being sold in the stores, you do have folks testing these products as well. I mean, obviously, you don't want to be distributing products that might poison somebody or make somebody sick, but there's also a lot of legal liability as well.
Okay. Well, Dianne Hillhouse from Olympus, thanks for joining us today. And be sure to join myself and Dianne for the live webinar that Dianne is presenting next week, Prevent Alloy Mix-Ups and Take Control of Your Supply Chain. That's taking place live right here from our studio in Chico, California, this coming Tuesday, December 6th at 2 p.m. Eastern, 11 a.m. Pacific. Dianne will show and discuss everything that she just talked about, but as well she's going to show the features and functionalities of a particular handheld XRF, the Vanta XRF from Olympus. So be sure to join us for that webinar, and it should be interesting. A nice little techie webinar.
Yep. Keep an eye on your inbox.
Yep. Thanks, Dianne.
Thank you so much.
Thanks,
See you next
Dianne.
week.
We'll see you on Tuesday.
All right.